All right, we're going to use the calculator again for this problem. This problem gives us a function f and says how many times does it change concavity in the interval from 0 to 2 pi n. So what we're going to do is just look at the interval from 0 to 2 pi and count how many times concavity is changed on this interval. Then we can multiply that number by n. So come over here to your graphing screen, and I need to remove my prior equation. This equation, I need to go back and check, x squared plus 5 cosine x. So let's type that in, x squared plus 5 times cosine of x. Now, what I actually want to do is look at the second derivative, because I need to know where the second derivative changes signs. That's where there will be a concavity change on the function. So I'm going to do second 8 for derivative, and I want the derivative of the function in y1. So I'm going to say y1, open paren, of x, close paren. Hit comma x to let it know that you're looking for the derivative with respect to x, and then comma 2 to tell it to do the second derivative. Hit enter. Now do you see the Leibniz notation that shows that this is the second derivative? That's where you know that you typed it in correctly. So go back up to y1 and hit F4, which will remove this check mark right here. I don't want to see the graph of the original. So hit F4. That way the only graph I will see is of the second derivative. Now my domain was from 0 to 2 pi, so I'm going to change my window, and I only want to look at the interval from 0 to 2 pi. And I'll make my x scale 1. And my y min and y max, I'll go from, say, -3 to 3. All I want to see is around the x-axis. So now I think I've got a good window. Let's count how many times the second derivative changes sign, because that will tell us how many times the function changes concavity. And when this stops saying busy, I'll know the graph is done. But it looks like 2 times on the interval, which means 2 times on each interval, and there are n intervals, so the answer will be 2n, which is E.